we start our lecture. Today we'll talk about detection and classification. Detection and classification, and based on the first CNN. So we already talked about so for the backbone, we already talked about the net, the net 5, AXNet, and VGG, and ResNet, also GoogleNet. So those are the basic backbone for the feature extraction. Okay, and feature extraction, the purpose for the backbone is the encoding and the classification. But its best is encoder. But then more application is the detection and the classification. Because for the classification, you should plot the object and try to classify. But it's inconvenient. For example, for the classification, we need to plot this car and input to the encoder, and for the classification, or plot the human, and for the classification, that's inconvenient. The convenient way is that if we can just input the image, and then they can automatically to do the detection and then classification. That would be convenient. So that is why we right now we talk about we call multitask, or we call detection. Multitask is meaning we have a bounding box. We also do classification. So more than one output, we call multitask. So that means we have at least 2 loss function. One loss function for the regression, for the bounding box detection. The other one is for the classification. So 2 loss function. So that kind we call multitask. And this is more useful. Okay, so this is what today we'll talk stuff from the RCNN and FAST. And the important one, the best one is the faster RCNN. And based on the faster RCNN, we will implement to the mask and then UNet. And last week we talked about UNet. UNet is also very powerful and simple. In the other direction, they go to YOLO. And YOLO is for what? They want to be faster. It means speed, be faster. But in the beginning of YOLO, like YOLO 1, V1, V2, V3, they pay more attention on the speed, but the recognition rate, the accuracy is a little bit lower. And the other direction is the retina. Retina performance, the accuracy is high, very high, compared with YOLO. But the speed is a little bit slow. But actually, the speed for the retina is still like around 30 frames per second. So it's good. It's good enough. And YOLO probably faster than 30 frames per second, like a 60 frames per second. Actually, we don't need a 60 frames per second. 30 is good enough. And YOLO V4 will combine the YOLO V3 and RetinaNet based on the YOLO V3 and RetinaNet. Okay, so they have a better result and fast. So the advantage for YOLO V4 or even V5, V7, and right now V8. Okay, the speed is good. However, the speed and the detection rate, classification rate is good, but the weakness, the disadvantage is that's complicated. It's not easy to modify. So if you just want to use it, you can use YOLO V4, V5, V7, V8. If you just want to use it, or just train it. But if you want to modify the network, like my level, we modify the network, I would suggest you don't use the YOLO because it's not easy to modify. And the other thing is that YOLO is this one, include faster, from faster RCNN to here. There's a little bit like a general purpose. General purpose meaning they try to classify, like imagine it, like a COCO. Okay, they try to classify 80 classes or even 1,000 classes. But most of our case, we don't do that. Like in my lab, we do what? We do the non-larger detection. We do the ball detection. That's a simple one. So probably you can think about use, in that case, probably you can think about use UNet, because UNet is simple. So what kind of situation you will use YOLO? What kind of situation you will use UNet? For the general purpose, just use it, you can use YOLO. But if your research, you already have the target, like I just said, we want to do is for the non-larger detection, the cancer, the tumor detection. It's just a few of classes. I would suggest you to use UNet. But original UNet is only for segmentation. But actually, the network for the UNet or network for the YOLO, you can just change the head. We have a backbone, we have a neck, we have a head. The head is rely on the loss function. So the network can be the same, but the head, if you want to use the segmentation, you just use the loss for the segmentation. If you want to use the bounding box, you can just use the loss function for the bounding box, either one. So in this one, so the basic is like a first RCNN and mask RCNN, for example, their network is the same. The only difference is loss function. So the loss function for the first RCNN is a bounding box and classification. For the mask RCNN, for the head, is a segmentation and the classification. Okay. And then based on the UNet, this one they include encoder and decoder. Okay, that kind of case sometimes we call auto-encoder. First, the RCNN is rely on the encoder, but their decoder is not doing well. I will explain to you later. The mask is, but this can change it to be the same as the UNet. So UNet is from the modified from the first RCNN, and all of them is auto-encoded. And auto-encoder, later on we apply on the GAN. We apply on the different kind of application. So back to here. So for the object detection, this is for the classification. The backbone is for the classification, extraction and classification. For the detection, it's bounding box or pixel segmentation. So the history, this one, with the same start from region, RCNN, and faster, and start have a YOLO. The same, if I say, if you compare which one you will use, if you want to consider the speed, probably you can use YOLO. But if you want to consider the performance, the accuracy, you can use based on the faster. Okay, so both the correction rate, this is higher. The speed, this is higher. But actually, faster RCNN is fast. It's 30 frames per second, so still fast. And YOLO probably 60 frames per second. But we don't need that kind of a high speed. And then so YOLO V2. And then the other important one is the FPN, Feature Pyramid Network. It's for sampling, for upsampling. In the other class, undergraduate class, I teach YOLO V1, V2, V3, V4. And YOLO V1, V2 is only encoder. V3, this one. V3 has decoder. But V3 uses Feature Pyramid Network. Use this one. So before FPN, all of them focus on encoder. After FPN, because FPN is NEC. It's NEC. NEC is for what? Decoder, for upsampling. So after FPN, people start to include FPN to their network. So we have an encoder, decoder. So FPN is important. So after this one, they have a retina net. And retina net is important because they modify the loss function. They improve the loss function of loss entropy. So it has better results. So year 2017, this paper focused on head. After that one, people did not pay attention on head until recent 2 years. Recent 2 years, people start to pay attention on the head, the loss function, by what? By constraint, by additional term. This term is the same as Lagrange. Lagrange have one more we call regularization term or constraint term to improve the result. So after retina net, people don't do that until recent 2 years. So they continue. So YOLO V3, they consider some process of a retina net. Okay, so have a YOLO V3 and YOLO V4, something like that. Okay, so for example, I back to the first RCN and mask RCNN. So given the image, right, and first is meaning the initial first RCNN, initially they use one more important one we call anchor, ANCHOR. First RCNN, the one important one is the anchor. I will teach you very soon. So suppose anchor is what? Anchor actually here. This one. We call region proportional network here. So input, they have initial detection of bounding box. And the second, so with two loss, one loss, second loss. I will explain this one later, very soon. Okay. So back to here. So the red color bounding box is using the anchor, using the region proportional network, have an initial detection result. And you will see the detection result is not so good. Like this car, the initial detection result is too wide, too large. Like this person, we want to detect the person, the initial result only head. is too small. Okay, so this first loss function based on region proportional network, and the second loss function will improve this result to be the blue color. Okay, so first RCNN is we call two stages. The first stage is using region proportional network by anchor to have an initial result, and then continue to use the second loss to improve the result. And mask RCNN is almost the same. The difference is they do not use the bounding box. They use for each pixel, they do segment the boundary. So the result, the shape is more, the accuracy is higher. The higher accuracy. So they consider the boundary. So that's meaning each pixel, the first step, the final one, they will use each pixel, they will classify to foreground or background. So we call pixel-wise segmentation. And pixel-wise segmentation is a binary classes. It's for foreground pixel or background pixel. And each one, either one, after you have a bounding box, and we do the classification. I just say again, for the bounding box, okay, they have the same, they have a binary classification. They'll classify inside the bounding box, the region is a foreground or background. So their result for the bounding box is a XY, is like a center, and WH is a width and height, and one more term is confidence. So the 5 parameters, and parameters C confidence is a foreground or background. And after this one, they have a second loss function, and based on they can refine the bounding box, and also in each bounding box they can classify like 80 classes, like 1,000 classes, the second loss function. And for the mask RCNN mask, they do the pixel-wise segmentation for the foreground and background 2 classes. After they do the segmentation, and based on the segmentation region, they classify to be like 80 classes or 1,000 classes. Okay. So we continue. So but in this lecture, we'll pay attention on this one. This bounding box is faster CNN. Okay. So we'll talk about the history of this one. The same faster RCNN we call two stages. Have 1 stage and 2 stages. 2 stages, they have an initial proposal. What's proposal meaning? Also, proposal meaning prediction. Proposal, when you read the paper, they tell you they have some proposal. Now, proposal is meaning with a prediction. So in beginning, they have an initial proposal, initial result is a red color. We just talked about that one. So the result, the detect of the object proposal is incorrect. The accuracy is not so high. Also, sometimes have some are incorrect. So we need to have a second loss function to refine the bounding box. So we have for the faster, we have 2 loss functions. One is this one. We call RPN, region proposal network, RPN. The second is this one for the refinement, for the classification. So the history is here. For the region convolution neural network, the history here. So I will explain the history and show the result to you. Okay. So in the beginning, it's called region convolutional neural network. It's here. So in the beginning, they use computer vision for the detection. They use CAN based on the region. They do the extraction. And then they use supportive vector machine, SVM, for classification. That's the beginning, the initial idea. I forget which year. I don't like probably year before this one, before year 2015. So the people's, this is history, important that you understand what people think about. The history is always important. So you can, if you have more experience, you can predict the future. 这有很重要哈，但是经验每个人经验不一样哈。你如果经验越丰富的话，你可以根据像我就一直在整理这种历史，因为我在外面当顾问，那常常要跟公司建议说你后面要往哪边走。那我带学生30个学生，我要去 predict 2年后，我没那么厉害 predict 10年了，我没那么厉害。在 predict 2年后。3年后，因为2年后是告诉你们硕士毕业，不是5年后，大概最多到5年，那会往哪个趋势走？那我现在那个deep learning 来讲的话，我实验室是2014年开始做，实验室我发现，所以2014年我们实验室就全部开始往 deep learning 走。我觉得应该是台湾算比较早，很早的实验室开始往这边走，就全部大家都开始攻这一块，这样，所以到现在算比较早。那我这门课也很早教，记得这门课教很久，就我说讲 deep learning 我已经教一阵子了，算国内算算都比较早的。那为什么有这些经验？那像我们跟公司那些董事长、总经理都会问我，连老师，那个。2年后大概什么趋势？3年后什么趋势？他们也要做大老板，他们也要去 predict， 所以我们会交换意见。那我跟很多就一些大老板常就会听到很多资讯，再去做修正这样子。那像 GPT， 我们大概4年前、5年前就开始做了。那结果什么？就输 OpenAI， 大家都输它。为什么？因为它有4万片，它有4万片那个 A100、H100，所以我们学生弄 GPT 跑了，跑一个可能要3年，3天、4天、5天，他可能1个小时就跑完了，所以那时间所以大家都输他，因为他就砸钱下去。那这事实上又有一个问题，为什么？什么问题？微软号称他们是要绿能，要减少碳，公司要减少碳。哇，我预期以后会几年以后就什么零碳什么的。就他投资 OpenAI 1年的碳含量到比什么一个国家还多，所以他不敢把 OpenAI 弄到，就是还是叫 OpenAI。因为弄进来，微软整个含碳量就暴增这样子。那另外一个一样，我讲 server， 因为2014年开始做，我们就就慢慢在接触，然后跟那些大老板聊天，所以我就最后发现，应当是要做 server 平台，就 AIoT 的平台 ，cloud 就那个 AI 的。Edge Cloud Computing， 那第二个就是 Edge Device， 就这2段，所以我们实验室也是往那边去走。那很高兴也谢谢敏球运算学院给我们800万，那我们去把它建立终于实现，花半年时间把它建立那个平台。所以我们现在有16个老师，30几个学生都要用那个平台。那我会继续扩充，因为那个没钱了。那 A100 我们花800万建立平台，然后只买2片 A100，因为一片 A100要那时候是去年40万嘛，不对不起，半年前我们是这半年才建立起来，半年前40万，现在50万，一张就10万，那两片就80万啊，那个建立那个机台，就是那个不是那个主机啊，主机要80万，所以80万加88这两片，一片40万，80万就160万，所以我们把整个花800万把整个平台架起来放回明球那边，谢谢苏校长那时候帮我们。好，那回到就是 prediction 这边，那我们来看这个 take a look about this one. So in the beginning, people think about we have a convolution and we have AXNet. So actually, people pay more attention on deep learning is from AXNet. They win the game, win the competition, and their recognition rate compared with the second one probably 20% higher than the rank second one. So people pay attention on this one. 我忘记 AXNet 是什么时候 ？AXNet 2012年嘛，2012年他们赢到冠军。那我实验室还在犹豫，那最后我2014年投入进来，可那时候很辛苦，为什么？因为只有 AXNet， 没有 VGG， 然后 AXNet 很难用，结果也没有比较好。AXNet 结果就他比赛得冠军，但是我们拿来用我们的没有比较好。那这时候遇到一个问题啊，那你要不要坚持下去？那我实验室怎么做？我只要把学生分两边，一边走传统方式，一边走那个deep learning 方式。没有输啊，都没有输啊，怎么教？这还好，实际上也是 VGG 出来以后，就 VGG 出来以后才真的是，真的有比较合理了，也比较看得懂，不然这时候不容易懂这样子啊。所以2015年 VGG 出来，那还好已经有1年的基础，所以就追得很快这样。不是追得很快，就是走在前面了。好，我们回到这一边。Okay, so people use this one is a computer vision, and supportive vector machine is a machine learning. This is machine learning for classification. And then over SPP, I will talk about SPP soon. So the year 2015, Microsoft the Her 那个 HE 那个和什么的非常厉害，非常厉害。这些人都是他发明的，在做 faster 跟 faster 这样。Okay, back to here. So they still use computer vision, use CNN, but the SVM, because SVM is machine learning, so they don't use machine learning anymore. They start use loss function, use neural network instead of SVM. Again, here, original for the classification, people use the machine learning method like SVM, like the LDA, something like that. But year 2015, people start using neural network. This FC here I call fully connectional network. Actually, it's a neural network. So they have a loss function. Start have a loss function here. Why? Why they use network? Because CNN is a network. So they use FC so they can connect together. What's SPP for? SPP is for normalization because your input image size is different. Here, the input image size is different. But FC is a neural network. They have a flatten, right? They fix the input node, number of node. So in order, here the different image size, here is fixed size. So it's not flexible. So what people do is here try to have that flatten the input resolution, input dimension will be the same. So they use SPP. So SPP is for what? To change any size of image to be the same size in order input to the neural network. So they use this one. But they still, for the detection, they still use computer vision method for the detection. Until faster CNN, they include we call region proposal network. So they have a complete here. They have a complete complete network instead of a computer vision. So faster RCNN is probably the first detection method. They complete use the network. Sometimes we call graph, G-R-A-P-H. Your node, have a node, have a connection, right? That's a graph, G-R-A-P-H. 图学理论嘛，图学你们讲图学有 node 有 connection. So they have a CNN, RPN, they have a fully conditional neural network. But here, the same problems because they want the input image size can be random, can be any. So here they use fully convolutional neural network instead of fully connection. So here I define fully connection network I call FC, fully convolutional network I call FCN. 不然这两个都缩写都一样啊，不好分，我就把这两个这样分。所以解决了，它这里解决了 any the different kind of input size， 这里解决了。但是有引入一个叫 ROI Anonymous Normalization， 是也是一样把 size 都一样大小，这我们待会会提到。但是这里有个问题，this one problem is this one is not neural network. I will talk about this one later. 那一样，你有这个架构以后，所以 even though right now, even though YOLO, they use the same structure. So we have a convolution for encoder, and this one RPN is for the initial bounding box detection, and here we call anchor and normalize, and use FCN for classification, for refinement. So I have two rows, one rows here, the second rows here. And mask is almost the same. The only different is here, the head. Okay, so that's the history of the region proposal network. Okay, so what's RCNN? Back to the beginning. So RCNN, the initial idea is that if I input this one, and we can use traditional method to do the detection and do the after each region, and we do the classification, use SVM. That's original method. Okay, original method is computer vision, use selective search. This one method called selective search. They can do the object detection. So on each object, actually, we can do normalize to the same size. And based on the same size, we can use SVM for classification. Okay, but people find out, like what I said, people find out if there's only one region, if I can extract more information and the classification result will be improved. So that's why people use convolutional, like edge detection, the filter. So they have a different kind of filter for each region to extract the different information. So they have a feature map. So original is one image. After CNN, probably they have a 128 feature maps for the same region, but they have more information they have a different kind of extraction features and input to SVM the same. So the result is much better. So this one, the purpose for this one is encoder extraction. Okay. So after they have an RCNN, people think about what's the inconvenient. Here, what's the inconvenient is detection, because this one cannot be one network. So that's meaning each time the input one, you should use computer vision method to get the result. And after you run the first algorithm and get a result, you based on the result and you input to the second CNN and get a result and you input to the SVM. So you have three stages. 有3个 stages 就不方便，因为你就变成你不能连续啊，就是做一个 stage 1以后，你把这个结果收集起来，放到第2个 stage， 放到第3个 stage， 那你 training 也很麻烦啊。你 training 这个独立 train， 那这个独立 train， 那这个独立 train， 所以你要分3个来做 training。So what's the engineering do？ 你是工程师嘛？我们是工程师哈。台湾叫 CSIE 嘛 ，E 是 engineering， 我们是工程师。那美国叫 computer science， 它叫 science， 这2个不一样。engineering 跟 science 不一样，engineering 是工人你知道美国的 engineering 是什么吗？我那时候常出入境啊，那时候当高阶主管常出入境，那个海关不是都熟了，就是海关有时候哦 ，you are engineering， 然后他问我说，然后说，他说，那你出国是去建哪一条铁路？那个建铁轨那个叫 engineering， 好像是我忘记是开那个火车头的叫 engineering 那样子，我真忘记了。我那时候我从读硕士的时候，我们班上就我一个外国人啊，其他都是白人。你不要以为那个白人很多，只有白人很厉害的白人这样子。我去 CMU 的时候，我是我们另外两个台湾，然后其他是北京清华大学的，其他都是美国人，都白人、黑人有少数黑人、白人，所以白人很厉害的很多。那我那时候去 CMU 的时候，才知道那个原来大陆最厉害的那个 engineering 是北京清华大学，他们有分哦，他们文学院好像比较弱，文学院好像是北京什么的，我不大清楚，但是我知道北京清华，那他们每个都是省状元，真的很厉害。所以我那时候跟他们蛮好的，所以政治归政治的然后一般人就归一般人，所以跟他们，因为我说都中国人，所以中国人、台湾人会聚在，不，黄种人会聚在一起。我们那时候日本人是日本公司来的人一堆日本人，他们公司 Sony 啊、Toyota 送来 CMU 那边取经嘛，他们交换2年，这是他们很好的一个策略。他们日本很早就来，都会到那种美国先进的实验室，花很多钱，那跟我们做研究，那我们从他身上学到很多技术，他也学到我们最新的技术，这样子OK， 然后那个就我讲的，我原来才知道。那个北京清华的是叫省状元，这很聪明那真的他们很厉害。还有我没有输他们太多 ，OK， 那是那边，但是我一说白人还是占多数啦。我们回到就 engineering 是他们在开玩笑，过海关的时候，那我们再继续。So people think about how to improve this one, but before we talk about first RCN improve RCNN. So we would like to talk about the extraction. So this part, the CNN at that time, they have a AXNet. So AXNet have 3 maximum pooling for downsampling. So AXNet, what's the advantage for the AXNet is that they start to use ReLU. here the net they use sigmoid. The net use, but they only have 2 layers. SNet have 5 convolution, and they start to use the loop a little bit deep, and they use maximal pooling, but they only have a 3 downsampling. Okay. And the second one is because we want to normalize here. Here we want to before we input to the SVM, we want to normalize the result to be the same size. So here they introduce we call spatial perimeter pooling network. What is this one? This is important, even though right now. And right now people modify this one to be like a ASPP, right? Or SPP. Okay. This is this way. Each time when you have detect the bounding box, for each bounding box, this one, for each bounding box, this one, they do the average pooling. So become 1 unit. But this one is better to explain. So each bounding box, okay, here, they do average pooling. So become, suppose here, this one, I said right here, suppose original, this size is 13 by 13 by 256 channel is mean feature map. Suppose original, this one, feature map, 13 by 256, suppose this one. Okay, and for each region, they do average， 就把它总和加起来变成一个值，所以但是它有256 feature map, so their dimension will be 1 by 256 dimension. 每一个 bounding box after this one, they have only 1 value to average for 1 feature map, but total have a 256 feature map. So the dimension will be this one. For the same bounding box, they divided by 4 parts. Each part, they do average pooling to be 1 value. So this, the same bounding box, they have a 4 values. 4 values. So here, each one, they have 4 values because each rectangle, they have an average pooling. So become 4, like the 4 small region times the same. Each region has a, because you have a feature map, so 256. So the same is 16. So total, they do the flatten. So total have a 16 plus 4 plus 1. So 21. 21 dimension times 256 feature map. So total dimension is 21 times 256. So no matter what kind of a bounding box you input here, each bounding box, their feature will become 21 times 256. So this flatten will be fixed. And then the input to the fully connectional network. So this one for SPP, this one. So this for normalization. So SPP here, SPP is for normalization. Okay. So after we have a SPP, so people start from here, from RCNN 1, 2, 3, 3 individual parts, they become here. But the same for the first RCNN, okay, their detection, they still use computer vision method for the detection. 你要注意一下，我教这个是这个目前还在用哦， 就是到目前我们看 paper 到2023年，大家又回去从 faster RCN 的观念来改哦，不是都用 YOLO 是你们在用，我们不用 YOLO， 很多人都应当是台湾很多很厉害的人都不用 YOLO， 他们我们自己会改。那我才说，那就又回到 fundamental 的 fast RCN， 我在这边讲。So here your detection they use computer vision, but after this detection, all of them are neural network. Sorry, we call convolutional neural network, CNN. So let's see. First of all, they do feature extraction over entire images. So they do feature extraction. That's meaning we have an encoder, have a feature map. So here. And this one, we already have this region. So that's meaning after you extract the information, and you can just select the region you are interested. We can call ROI, region of interest. ROI is meaning your detection result. Okay, so I say again, this one, you do the encoder over entire images. So here I have many of feature maps. 这就很多 feature maps 啊，然后这 feature maps 你只考虑到，因为每次假设只有一个 region 就考虑一个 region， 两个 region 考虑两个 region， 是从一般的 computer vision 来的。好，那就把这个萃取出来。那你把这个经过 we call ROI pooling layer. Here is one. This one is a SPP. 你把这个萃取出来啊，那你因为这里都是用 here or FC is fully connected. It's meaning neural network. So you have one neural network second or 1/3 or 1 second, 1 second. This one is for classification. This one is for bounding box difference. But before you do that, we have a normalization based on the dimension normalization based on SPP. So SPP, you have region. You extract the region. So this one, and do FCC, try to do classification. And so let's share. This one important. See, this one classification is discrete. This discrete. This is continue for bounding box. But let's share the same one. That's meaning what? Meaning actually you can do is one individual loop to here, the other individual loop to bounding box. You can do that. But to reduce the parameters, you want to reduce the parameters, so this one can combine together. And until the last few layers, you do separate and use different head, different loss function. 这里注意一下哈，我刚刚讲的注意一下，这是可以独立两个，但是你可以减少参数量，所以可以共用一个。就前面假设你总共有两个 ，suppose you have only two layer, one layer, two layer, one layer, two layer. So you can 1 plus 1, individual one. But you will take a lot of parameters here. So if I combine here, and then until the last one, I separate. So this one is for the extraction is the same, but for the different head, I use one for classification, the other for the regression. So network 好处它可以 combine 哦，不用花那么多参数。好，那 loss function is here。时间到了，我把这个讲完，就把这一页讲完。所以 difference is the loss function. So one loss function, second loss function. So we call multitask. So the first loss function is try to classify. This already have a responding box. I want to do the classification. So suppose I have 80 classes. So I want to classify 80 classes. So this classification here. So I have 80. So I use the simple cross entropy. So if it's 1, and I try to, this is a prediction result. The same, this is no good. Don't use this one. This is a basic cross entropy. But the basic cross entropy is no good. You are better use focal loss. Focal loss is from retina. Retina is better, has a better cross entropy than this one. Okay, and the second one is regression. And regression, we teach you in the beginning, we teach you use the mean square error, right? Again, that's not good. Right now, many people use L1 smooth, is this one. And L1 smooth, I'll explain to you later. So this result is better. 那后面我有讲到 L1 log 那个 smooth this result is better than mean square error. It's continue for regression 就逼近，只要2个。好，又最后一个问题。This discrete, this continue. So the unit is difference. 单位不一样啊，你2个单位不一样啊，你会遇到这个问题哦。一个是分类啊，一个是连续的啊，相减起来的 loss 完全不一样，怎么办？ So we have a waiting here. So this one actually kind of Lagrange， 这跟 Lagrange 有点类似哦，对不对？一个方形加一个，那一样，这个你可以把 local 这个可以当成1，那 lambda 再放在这里是一样的意思 ，lambda 放哪边都一样，这是 waiting。那这个很麻烦。What's the value you want to give to the lambda？ 很麻烦。Now more papers, if they are nice, they'll tell you their experience. Some paper they won't tell you what's the lambda value. So you need to test, but not easy to test. But there are papers talk about how to estimate the lambda. 我有看到不多，有一些 paper 他会教你怎么去把 lambda 找出来，这样子。那结果是什么？结果你看完那篇 paper， 还不如还是字比较快，因为那 paper 讲得很复杂，他理论上跟你讲，哇，这样做，像 EfficientNet 一样这样做，然后你发现最后好像还是直接试试看比较快。我不是说 paper 不好了，但有 paper 在讲这个，有些 paper 还是讲得不错。好，那this is for first class, and next hour I continue to talk about this one. So we take a 10 minutes break until 10:15. 我们休息到10:15哈。